Oh, now you're not awkwardly leaning.
What was that?
Now you're not awkwardly leaning. So were you guys tracking the SN15 rollout?
I was up until we went live. And what's the weather? Is the TFR
It's
still
canceled. It's
in
canceled.
place?
Yeah, the flight's canceled. Yeah.
Weather?
I don't know what scrubbed it. Yeah,
Okay.
scrubbed. Anyway, scrub it up. Everybody in the tub.
That sucks.
Yeah, I mean, I don't know. It's just, I mean, I'd rather have a scrubbed launch than an exploding launch.
Oh yeah, totally.
So
They were having issues with there was a front, I want to say, to the north that was an issue.
Yeah.
Sorry, I'm setting up recording software in the background, so I'm looking all over the place.
Yeah, you don't mess around with the weather.
No. And after we weren't able to see what went wrong with the last launch that was Soyuz style through fog.
Yeah.
Soyuz has been around longer than I've been alive. It's allowed to pull off that stuff.
Yeah, that was a good example of them messing around with the weather with SN 11. Yeah, the one with the fog.
11.
Yeah.
And tomorrow, Crew 2 comes home.
Hopefully, if the weather doesn't, because apparently there's problems with the weather as well for them, so that's delayed their return. So there's like I think 11 people on the International Space Station right now. There
are.
Yeah, they're jammed in there.
Party.
Yeah, exactly. Yeah, they're really jammed in there. You know, fortunately, they are able to exist in 3 dimensions. They're able to use every dimension of their space, and so they could be coming and going above and below each other because you're in microgravity. But yeah.
Still, that was the wrong keyboard for the wrong computer.
And then the 4th flight of the helicopter was delayed.
Yes. Is it 6:03 or 6:04 today?
This is 6:04.
Thank you. And so it's like and then the other night there were like 3 launches in 2 hours.
Yeah.
It was just insane.
Yeah, another Starlink launch. Benlow is saying, Fraser, you were right about the Invincible. Episode 7 was awesome. Wait till you see episode 8. It came out last night. It was crazy. I'm now going to definitively state Invincible is the best comic book superhero-y media ever made.
And this is on Amazon Prime.
It's on Amazon Prime, yeah. Yeah.
Okay.
So I would say it is better than any Avengers movie, better than any of the Marvel movies, better than The Watchmen, better than The Dark Knight, in my opinion. The Joker, Dark Knight was pretty good.
The Joker is its own thing.
Yeah. Ian, I don't have to press record when I'm doing Astronomy Cast because I don't record with this camera. I just use this camera for the video. Joker was Joker was fine. No. Invincible is way better than Joker.
So the Joker was more of a psychology of a broken human criminal show than comic book.
Yeah, it was fine.
If you put it in a different bin, it was much better than if you view it as fun romp. Not that Jessica Jones was a fun romp.
But yeah, I 10 minutes into episode 8 of Invincible, and I was like texting my buddy, texting Jay, and I'm going, episode 8 is out. Holy F. As I was, I was actually swearing how crazy it was and where they went. Yeah. Can't be better than Deadpool. Yes, it's better than Deadpool. Yes.
I'm currently watching Turkish sci-fi on Netflix because that's a thing you can do. Mm-hmm. It's dubbed into English and it is very pretty and has a plot. I'm watching The Protector, and it's that perfect level of keeps the part of my brain that would otherwise be saying working on email sucks, go do something else. It occupies that part of my brain. So I can feed it to my brain while I get a whole bunch of email triage. There's some TV I can't triage email while watching.
We'll multitask. So I'll be like, reading Twitter or reading Reddit while we're watching other shows. But no, when we're watching Invincible, I'm just like totally connected to it. So,
Have you seen Shadow and Bones yet?
no, is it any good?
Yeah, it's
good.
really good. I'm actually going to go back and rewatch it because the details in it are so good, and I know I missed
Yeah.
stuff. Yeah,
We watched
it's a fantasy, not comic book, but it's
the
a good one.
we tried watching this Nevers thing, but then I realized it was done by Joss Whedon. I was like, nah.
Yeah.
Yeah. Wasn't very good anyway. So, what do we do? Oh, I'm going to say hello to some people. Hold on, I'm going to say hi to some people.
Okay, I'm going to open more references.
Hello to Ben Lowe, Beth Johnson, Bort Clankar, Cherry, Corey S., Fernando Salazar, Gordon Dewis, Greg Nickel, Guido Bibra, Ian Farquharon, Innermost Basics, John Sheffield, Larry King, Luke Duke, Magnus, Paul Disney, Arjone, Roman Geber, Zapfan, and I'm assuming there's other people who said hi as well. Subject line. Yeah, people maybe said hello earlier. Yeah. Okay, I'll try Shadow and Bone. That sounds good.
Yeah. Do recommend.
Okay then. All right, I think I'm ready.
I think so too.
You think I'm ready? Okay. Well, if you think I'm ready.
I need to remember to use the correct mouse. Okay.
How many mice do you have?
So for Daily Space, we have figured out, because my brain was breaking trying to produce and be on air. You've seen me do this on Astronomy Cast. Brains, it wasn't going well.
Yeah.
And so Allie is remote desktoping she's team viewing into my desktop computer, my tower, and producing everything, but I still need to be able to see my notes, see my script, see everything else. So because I have a 3-screen setup, I was like, I'll just connect the center screen to my laptop. So left hand laptop center monitor, right hand wing monitor with the tower. So
right. I will probably have to do something similar to you. I'm building up the parts to start using my MacBook Air as my streaming machine, as my primary machine, and I can hook it into my various monitors, and I've got a separate external port. I actually don't have another mouse. So I'm having to sort of unplug all of my stuff from one and then plug it all back into the other. And so, yeah, I think I'm definitely one mouse away from your situation, because it's just loud. Like the MacBook Air is silent, has no fan. It just makes no noise, while my PC sounds loud. Here, listen. Everyone listen. Okay, you don't say anything and I won't say anything. I'll mute my microphone so you can hear the difference. So there's like a background hum that's there, and I'm going to get rid of that.
Yeah, I had a moment last fall where I was like, I haven't left my house in a year. I have extra money. I'm tired of things lagging and getting frustrated with my production system. And I just bought a Mac Pro, like the tower that you can add stuff to and swap out. So I've basically gone back to the days of having a tower, except I got to keep OS X. So I'm happy.
When did you buy the Mac Pro?
I got it in September. I got it before the M1 chips came out.
Yeah, because these Mac Minis are like pound for pound, standing up pretty nicely against the Mac Pro.
Yeah, and well, not MacBook Pro.
No, the Mac Pro. Yeah. The Mac Mini is pound for pound, standing up pretty well against the Mac Pro.
For non-threaded processes. The second you start threading, the Pro wins. For unthreaded, the M1 chip wins every time. But when I was going to produce International Observe the Moon Night for NASA, it was a 5-hour stream, and I was just like, and I'm done. I am just investing in equipment.
Yes. Yeah. Okay, let's do our jobs.
Okay, I need to get my camera to stop vibrating. I need to add a weight to this. Okay, I think I got it to stop vibrating.
Okay. All right. I'm going to press record.
Okay. Oh, I should do the same, shouldn't I?
Yeah. That wasn't a threat. This was an offer to collaborate.
I pressed record. Hello, Rich. Hello, Allie.
Astronomy Cast, episode 604, Balloon Astronomy. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. We have hit full-on spring, like sleeves can go away now. It's kind of awesome.
Yep, I'm now in shorts for the next 6 months. No matter what the weather does. It's a hard switch over. I'll put a coat on, but shorts from here on out.
I feel this way about real shoes. I shall be living in sandals and Tevas from now on.
Yeah, perfect. Yeah, I know the weather's great. Except, of course, that means the garden is freaking out. And all of the dandelions and all the weeding that needs to be done, I'm spending so much time in the garden. It's just crazy to catch up.
Yeah, our back lawn is a mixture of clover, violets, wild strawberries, and onion and basil that went to seed and joined the lawn. So when the lawn gets mowed, it smells very confusing. Very confusing.
That's great. All right. So when you think about the world's observatories, I'm sure you're imagining huge telescopes perched atop mountain peaks or space telescopes like Hubble. But you might be surprised to learn that some telescopes are carried high into the atmosphere on board balloons. What can they accomplish? And we will learn that in a second. But first, let's have a break. And we're back. All right, Pamela, balloon astronomy, what?
This is one of my favorite things because it allows you to start to do the science that is most effectively done from outer space without the cost or, I guess, danger is too strong a word, but the same risks that are required to going to space. So if you're a graduate student and you want to develop an ultraviolet experiment, you can't do it from sea level. You probably can't do it from the top of a mountain peak. And launching things into space is getting cheaper and cheaper and cheaper, but it is still beyond the reach of your normal graduate student research fund. But a balloon, you can start to get above the parts of our atmosphere that block millimeter wavelengths, that block ultraviolet. And by getting out of the way of the atmosphere, new kinds of science can be done.
Aren't telescopes heavy?
Well, big telescopes are heavy. Not all science requires big telescopes, though. If your choice is no science or build things as lightweight as possible, you just build as lightweight as possible. And you have to remember that there are satellites out there that are doing amazing science, and they're the size of a car. Mm-hmm. And some of them are called things like Cassini.
Yeah.
And so balloons can actually carry human-sized cargoes, car-sized cargoes, which means small telescopes with lots of awesome instrumentation, totally possible to fly.
So let's talk about sort of the physics and the atmospherics of launching a balloon with some kind of telescope payload. So what kind of altitude are they typically deployed to?
What is amazing is some of them are actually getting high enough up that they are above the blue sky. There are balloons that go so many miles up that you aren't starting to cross that 60 miles you're in space, but you're close enough to that boundary that you look below you to see the blue sky. And even on the daylight side of the planet, you can see the darkness of space. As long as you don't look directly at the sun, it's still going to block the darkness of space.
And probably even like start to see the curvature of the Earth.
Easily.
Yeah, yeah.
Now, not all go this high. Many are just trying to get up 60,000 feet, twice the height of a commercial airliner. But they do go significantly higher for some experiments.
And so when you sort of imagine you've got these balloons sort of up at this kind of altitude, you know, we've seen lots of people launch like weather balloons, and they'll go and they'll put some payload, some stuffed animal or camera or whatever, and they'll put it on a weather balloon, and off it goes higher and higher and higher. And it always ends when the weather balloon pops, because it's expanding to the point that it breaks. And that's the inevitable end of every weather balloon that gets sent up. So why don't these pop?
Well, so in some cases they do, and we just have the instrumentation is on parachutes.
Right.
So there's during the 2017 eclipse, there was actually all across the United States a variety of different research teams that set up weather balloons, launched them precisely timed prior to the eclipse crossing their place on the planet. And from their perch high above the stadiums and schools and all the other places they launched from, they observed the passage of the Earth's shadow across our planet while also taking observations of the sun itself. And so in these cases, they in many cases did just pop. And parachutes are an answer. Also, some stuff just gets lost in the oceans. Some people just it's okay now and then.
But there are some that are designed to last a lot longer and not pop and actually regulate their altitude.
Yes. And so these more complex systems are what often get used for longer term experiments where folks are, for instance, working to measure the cosmic microwave background in high resolution from balloons that are able to carry instrumentation that until recently we weren't able to build and trust on orbit. Sometimes you want to launch things on balloons a few times before you build that billion-dollar space telescope.
I'm sort of imagining, I guess, with the ones that are popping, I mean, people launch telescopes on sounding rockets, and they have this parabolic flight. They go up, they come back down, and so you'd think a balloon that's going to take its time to get up is just as good as and probably a little more cargo than a sounding rocket. Maybe not. I don't know.
They've launched 36-inch telescopes
on balloons so then, once you've reached those kinds of altitudes, I'm assuming then certain kinds of astronomy become possible once you're up above the bulk of the Earth's atmosphere. So what regimes can you access at that point?
So this is where you start seeing ultraviolet, X-ray, gamma ray on the blueward side of what we see with our eyeballs. On the redward side, you start seeing the gaps that the atmosphere blocks that prevents us from readily seeing microwave wavelengths and some of the other molecular lines that our atmosphere basically says, hey, you can't see this part of the radio spectrum. So it allows us to see things our atmosphere blocks. And the most exciting stuff in some cases is what we're starting to see in those blueward side of things. Some of the coolest, earliest experiments just looked at our own sun back in the late 1950s when we really didn't have a space program yet. We were using balloons to, for the first time, see granulation features on the surface of the sun. And the first flights were taking photos and then rescuing the cargo. And it was only in 1959 that television transmitters allowed us to do real-time science from high atmosphere.
Yeah. So it's like this, we think that we have to have space telescopes, but in fact, there are ways to get at those parts of the electromagnetic spectrum that you wouldn't necessarily absolutely need to do. So we're going to talk about some specific missions in a second, but first, let's have another break.
Okay.
And we're back. So now we've talked about sort of what it's good for. So let's talk about some specific missions that have actually been balloon-based observatories.
The one that really, for me, brought it home how powerful this is Boomerang. This was a mission that took off in the late 1990s, and taking off in this case meant filling a balloon in Antarctica and circling the bottom of the world. Is that what we call Antarctica? And this was a cosmic microwave background experiment that predated WMAP and its amazing detail. And it was in Boomerang that we first started to see some of the hints of what would be possible. And we started to understand that we have the ability to use the cosmic microwave background to measure the expansion of the universe and get details out of what happened between the Big Bang and the, well, universe becoming what we see today about 400,000 years in.
Right. So with previous surveys, they were able to detect the existence of the cosmic microwave background, that it's there at the temperature that would be predicted. But the question was, would you see variations in the background? And with an instrument like Boomerang, they were able to start seeing temperature variations that could then give them hints of larger structures, and that would help connect the dots between the geometry of the universe and the and the sort of structure of what we see today. And as a precursor, it's sort of a really clever idea that you sort of build these precursor instruments, launch them, and then use that to then build a proper space telescope.
And just it's beautiful and exciting and harrowing science, because first of all, you have to construct something that is going to safely fly to over 100,000 feet, 42 kilometers up. You have to deliver it to Antarctica in this case. You have to stand out in the cold when the weather is just right, fill the balloon, hope nothing tears, hope everything goes smoothly, launch it up, hope that you can safely retrieve everything. Boomerang flew multiple times. And if it works, it's significantly cheaper than a spacecraft. You get to tinker with your electronics between each flight. This is real iterative experimental science that you get to play while freezing and possibly contemplating penguins.
There's some pictures that I've seen, a much more recent one. I think it was at Blast, or there was an even more recent one just a couple of years ago. And you look at the photograph, and there's like this crane truck in Antarctica where they're hanging the balloon and the instruments, and they're preparing to launch it. And you're like, yeah, I've seen a crane truck. And then you think, wait a minute, they got a crane truck to Antarctica, to the South Pole. And you're like, that must have been difficult. Yeah. So let's talk about some other missions that have done balloon astronomy.
So one of the more recent missions that falls into the category of science I didn't even imagine we'd be trying to do is an instrument called SPIDER. This is a polarimeter, which means that the instrument looks to see how the light is essentially rotating or oriented. Light is a wave that travels through space. The length of that wave determines the color of the light. But that wave with its amplitude has an orientation as it comes towards us, and it can even be rotating as it comes towards us. And so with polarimetry, you measure the orientation of that wavefront as it travels towards you. And this can tell us things about how light is scattered, what dust is out there, what magnetic fields are out there, what physics is causing light from different objects to either be randomly aligned or coordinated in its motion across the universe. Now, SPIDER, it's another one of these where we're going to do really cool science we can't do from the ground. It's looking in the sub-millimeter. And it's looking for primordial gravitational waves.
That's crazy. So you've got a balloon-based sub-millimeter telescope that's being launched that is searching for gravitational waves from the beginning of the universe.
Yes. You have to understand calculus just to read their science goals. It's that kind of research. But they're essentially looking for the kinds of things that might be seen in the cosmic microwave background that will explain to us what kind of inflationary universe was there, that might help us understand how our own Milky Way galaxy is interfering with our ability to see things beyond our galaxy. it's a super complicated mission with flight duration times on the order of 17 days. And so far, it's mapped about 10% of the sky. And like, I remember we were at a AAS meeting once when Sean Carroll was talking about someday being able to observe things that happened prior to the formation in the cosmic microwave background. And me and my little observational brain were like, no, I was wrong.
Yeah.
I was so wrong.
Well, I mean, this leads back to the Bicep 2 discovery that was made. And that was a telescope, I think, that was also in Antarctica. And where they thought they had detected these primordial gravitational waves, and it turned out to be dust, which it always is. But so they're actually, that team is working on another telescope down in Chile, but now you can see sort of iterate, just keep going with this idea and take it to the nth degree. That sounds great. And so submillimeter, that's a tricky wavelength for us to be able to see from the ground.
The OH molecule and water molecules in our sky are hard on millimeter and infrared.
Right.
And so for some of these redder than your eyeball can see, but not quite all the way into the radio wavelengths, you need to go up to where it's dry. You can do better by going up to the extraordinarily dry, high altitude Atacama Desert facilities. But a balloon over the desert of Antarctica, that's kind of the best you can do without actually going into orbit.
That sounds great. I like that. Do you have any other examples of balloon missions?
Oh, there's so many. And one of the things that really gets me is the earliest ones actually included humans. So
they flew with their telescope, so they observed. I just imagine that would be terrifying.
So the one thing that we haven't really gotten into is the difficulties of dealing with the fact that your instrument is on a balloon. Mm-hmm. So if you have a space telescope, you're gyroscopically stabilized, something spins, you don't move, you move around the Earth in a predictable way, everything is good. You build a telescope on the surface of the planet. You occasionally deal with earthquakes. You occasionally deal with wind noise. Tides cause your telescope to go up and down in ways that only matter with pulsars.
Yep. Clouds.
Pretty good. Well, yeah, I'm ignoring the weather.
All right.
With a space telescope and a ground-based telescope, you're not worried about the vibrations that you get with something like Sophia or a balloon. And with Sophia, you're not worried about getting spun around.
Right. In the jet stream.
Yeah, weather balloons are subjected to the jet stream. So, and all the high altitude winds, not just the jet stream. And so this means they have to figure out how to compensate. And so early on, they're like, we're going to launch humans, figure this stuff out. Humans are essentially in spacesuits. This is part of how we tested early spacesuits. And eventually, we just started launching the balloons by themselves, although controlling them still continues to be a problem.
That does sound a bit like a twofer, that you have an astronaut testing out a spacesuit and at the same time have them work the telescope. It's perfect. All right, we will continue this conversation in a second, but it's time for another break. All right, we're back. Okay, so with Last We Saw Our Heroes, they were talking about balloon-based observatories and some of the interesting missions. Now, there was, I mentioned it briefly earlier, there was this telescope mission called BLAST, which was another submillimeter telescope. And there's actually a pretty fascinating documentary that you should be able to find on one of the streaming services. I forget what it's called, but if you do a search for BLAST telescope or balloon telescope, you know the one I'm talking about?
It didn't live as long as it should have. It failed to live through its third flight and had to be rebuilt. They kept the name, but
yeah, so you can see
the same.
So I mean, imagine a telescope that you lose after the third flight, and imagine the trials and tribulations of taking this thing. did they launch this one from Antarctica or the Arctic? I forget.
This one was the one that dangled from a crane that you mentioned
Yeah,
earlier.
yeah.
And this was a 2-meter mirror sub-millimeter telescope. So it was another one of these really huge things. And it was used to measure the redshifts of starbursting galaxies to help pin down using photometry. So this is where you take filtered images and you measure the black body radiation, how it gets shifted by the redshift of the galaxy. So it was using photometry with filters to get at the redshifts of galaxies, doing all of this in the far infrared. And it helped us see just where are the starbursting galaxies in our universe. And it also, because you have to figure out where our own galaxy is when you're trying to figure out what's beyond it, it did high resolution maps of the infrared, far infrared emission of our own galaxy, so that we now understand, well, just what our own galaxy is changing the brightness of out in the distance.
Yeah. So anyway, if you can do a search on your Netflixes and your Prime videos, and you should be able to find this this telescope. I think we've got time for like maybe one more quick telescope. Do you have another one that you like? So, like there's X-ray telescopes, as you say, sub-millimeters.
So I can't say that I have a favorite of any of these, but X-rays are super hard to observe, people, super hard. In order to understand where on the sky X-ray photons come from, they use a scattering approach to scatter the photons onto a detector, and then they have a grid of opaque squares that casts a shadow, so they can figure out where the photons came from based on the shadow pattern of the X-ray blocking thing above it. And figuring out how to make that technology work, figuring that technology out was something that got to be tested by balloons before we launched things into outer space. So there was HERO in the early 2000s. There was HEFT. There is, and this one's name just brings me joy. There is Pogo Light. Pogo Light. And so these different telescopes allow us to test and do science and explore and innovate flight after flight, the technologies that either we just don't need to orbit or that we need to perfect before we orbit.
And I wonder then, will we see many more of these kinds of observatories into the future? I mean, the list that I'm looking at has about at least 12 plus balloon observatories.
And it's an incomplete list.
Yeah, there's many more smaller ones
every
as well.
University at some point or another has launched a weather balloon with science instruments, at least look at solar granulation for undergrads.
Yeah.
This science isn't well tracked. It's just published and done quietly off to the side without a lot of the excitement of a spacecraft.
Yeah, it's a nice middle ground. It's sort of like this. It sort of sets off the same delight as like Sophia when you think about them installing a 4-meter telescope on the side of an airplane and flying it at as high up as you possibly can to get above that atmosphere and turn it into a space telescope. It's another way. It's sort of, you really admire the ingenuity of the astronomers and the engineers who come up with these clever ideas to push the boundaries of what's possible.
And it's just beautiful. I really adore the images that come from these, where you do see that curvature of the Earth, that dangling instrument hanging from what looks like a jellyfish.
Yeah.
These are beautiful, elegant pieces of science hardware. And it's something that reminds you that there's a certain romance to science, even today as we move into this high-tech future.
Very cool. Thanks, Pamela.
My pleasure.
All right. Did you have some names for us this week?
I do, but I need to figure out what screen I opened them on.
And which mouse to use.
I think I figured it out. No, I have to click a link. We love all of you. Please stand by. Pamela is being confused. I'm sorry, Richard.
These are amazing. I'm just reading more about these telescopes.
Yeah, they're super amazing.
Yeah. Yeah, they like you think the balloon obscures the view from the telescope, so they just hang it on a really long wire, so that
Yeah.
the balloon is this tiny little dot above the telescope.
Okay. So, as always, we are brought to you by you. This show is made possible because we have a crew of humans behind the scenes that herd our cat like habits into being well behaved content hosts. Nancy, Beth, Rich, Allie, all of them are out there. And your contributions through patreon.com/astronomycast make this possible. We would like to say this week thank you to Paul Hayden, Mark Stephen Rasnack, Ronald McCoy, Brian Kelby, Marco Iorossi, Jordan Turner, Ravning, Aylin Price, Mark Von Coy, Sabri Lark, Vocal Warrior 24. I can say that one and it's cool. Leah Harborn, Mark Phillips, Matthias Hayden, Ruben McCarthy, Jeff McDonald, Wayne Johnson, Iggy Hammock, Catherine McCabe, Jordan Young, Burry Gowen, Birko Roland, Kevin Lyle, Jeanette Wink, Aurora Lipper, Joe Hook, David, Gerhard Schwarzer, Andrew Poelstra, Brian Cagle, David Truog, Robert Wenger, Venkatesh Chary, and TheGiantNothing. I love your username. Thank you all. You make this possible.
Thanks, everyone. We'll see you next week.
Bye-bye.
All right, and then they save.
And now they save. With that mouse.
I hope people.
I see you.
I hope people realize that if you really want to entertain Pamela, come up with a hilarious username. That there's nothing she likes better than a funny name. Yeah,
it's true.
Yeah. All right.
So my dogs have figured out that when I say goodbye, it means that the streaming is ending. And Malachi just came up and did the whole mom, can we go out? Can we go out? Can we go out? This is my dog.
Yeah.
And did the whole nose moves the elbow and everything else after
funny.
being utterly still and sleeping the entire time, or not sleeping and listening closely the entire time.
Yeah, mine is deaf, of course, so she can't hear us say these kinds of things. And so she's gotten really good at various cues. And so the one that she's figured out is, if I'm wearing my walking hat, so if I put on a ball cap or sunglasses, she gets really excited because that means there could be a walk. And if Carla, puts on her outdoor gear, the dog just loses it because, and then of course it's really sad when Carla puts on her outdoor gear and then goes to the dentist and doesn't take the dog. So the dog is sometimes sad. All right, we got a lot of great questions, so let's crack into them. Arjun asks, do they have special gimbling hardware for the instruments on some missions? We didn't really talk about that, but yes, yeah.
Yeah, so basically they need to be able to stay on target despite all of their motions, which means that the instruments are moving inside their cage to stay pointed where they need to be.
Yeah, you're hanging on this rope under the balloon, so there's going to be a sway back and forth. The balloon is going to be turning in the air, so you got to be able to gimbal around that. You got to keep the telescope stationary. So all of that technology comes to play. James Aberson says, I watched Dr. Becky's recent video on black holes. She said there's a star circling our galaxy's black hole at 8% the speed of light. Could it have planets orbiting it?
So that would be such a crowded part of the galaxy that the probability that any planets that formed with the star were separated from the star through gravitational interactions with other stars is high. High is not the same thing as they couldn't be there. It simply means they probably aren't there. And even if there are planets there, the probability of life as we know it, which is a caveat we always have to add, is lower because it's a higher radiation environment.
But I'm sort of imagining this planet, the star, whipping around it's going 8% of the speed of light when it's getting within a very short distance of the supermassive black hole. And of course, the planets are going to come along for the ride, but I wonder if that creates a three-body interaction between the black hole, the star, and the planet that would kick planets out.
It's going to depend on the mass ratios, whether or not you treat it as a three-body problem or as a tidal force. So it will definitely alter the orbit of the planet. Because when you're that close, first of all, the planets are going to get stretched and squished as they go around their star. There's a lot of tidal effects in there.
Yeah.
So that will affect everything. I don't know if there's a stable orbit that's possible. I just don't know.
Yeah.
But my stomach, which lies, but not always, says that if you have a massive enough star with a small enough planet close enough to the star that it can be held onto.
Because it's the change. I mean, as long as the change is happening equally to both the planet, the whole system on its own. But yeah, it is an interesting question. Okay.
Yeah.
So Pamela doesn't know. But I sort of think at the dense region around the galactic center, there are so many three-body interactions going on. Can't imagine that a star would be able to hold on to its planets when they're buzzing past each other within a light year. We talk about how there may be a star coming within half a light year of the Earth in a million years. I mean, they're going to be seeing close stars every 10,000 closer. Hal McKinney asks, would balloons work on Mars?
Not well.
I have an answer for this if you don't have one.
My answer is not well.
So NASA did plan an idea for a mission to go to Mars using a balloon. And I actually think Bob Zubrin from the Mars Society was one of the lead architects of this mission. And the plan was that the balloon would go, it would inflate during the day when the sun was out.
That's clever.
Yeah, and then it would raise up its instrument package and it would float around for a while. And then as night came on Mars, it would cool back down, it would lower itself back down to the surface, and it would rest sort of either really close to the surface or just the balloon part. I'm sure we've all seen this where your balloon is starting to run out of juice and it's sort of sitting there with the string on the ground, right? And then the next day it would lift back up, and then the winds would just carry it to wherever it needed to go. So it was a pretty clever idea, and it just has never been actually sent.
One of the weird things about this is it's here on Earth most of the time when you see hot air balloons, it is close to dawn or dusk because that's when the air is cooler and the hot air is significantly more effective and you can see so you don't crash into things. All good things. With Mars, because it gets so cold that you end up with less atmosphere at night than you have during the day, that less atmosphere becomes problematic. So, you want to fly during the day, during the hot of day. Here, our atmosphere will actually get thinner during the day because the density decreases as it expands.
Yeah.
And the atmosphere gets denser at night. On Mars, it gets denser and then freezes out of existence. And it's that extra phase change that makes all the difference in the world.
I mean, based on them flying a helicopter on Mars, you just feel like send all the things, right? But I did a video about flying things on Mars a couple of years ago, sort of even before the Ingenuity project was announced. And for a while there, the ideas were just, can we make something be in the air longer as it's coming into the atmosphere of Mars? That you would essentially, as it's doing its 7 minutes of terror, at the end, when it pops out of the aeroshell, little wings come out, and then the thing just uses a battery propeller or like some kind of hydrogen cell and tries to fly as long as it can until it crashes. So to go the other way and start with a helicopter that's sitting on the surface and it's recharging itself and then fills up its batteries and then flies around is incredible, is a fraction of the price of one of these. They would have been multi-$100 million missions when who knows how much this little helicopter cost, a fraction. So there was a question and I lost it. Okay, here we go. So Sir Goosey asks a question. If all the reflected light is polarized, but a starlight is not, can we use polarizers to dim the light star without dimming reflected light, potentially to find other planets?
So starlight is actually polarized. Not always, not all of the time, but like the very first research I ever did was measuring polarization parameters of T-Tauri stars using radio data. So yeah, starlight does have polarization. What was the rest of the question? I'm sorry.
Well, so could you use the polarization to find planets? Reflected light to find planets? The answer is yes. And in fact, there's an instrument that does this called espresso. Okay. Yeah. So on the Very Large Telescope, there is one instrument called espresso, and I don't know what the acronym is, but do a Google search for it. And it does exactly what you're describing. So essentially the light is coming from the star. It bounces off the atmosphere of one of the planets around it, and the light is polarized in a different way when it comes through that atmosphere. And espresso,
that's the key.
Yeah, and that's the key. And espresso is designed both to block, it has a coronagraph, so it's designed to block the light from the star, but also to be able to detect the different kind of polarization that is coming from starlight refracted through a planet's atmosphere. And they actually have taken pictures of planets using this technique. So do a search for espresso. You'll find a mountain of information.
Yeah, I think we talked about it in a show back in February, and then it fell out of my brain. But it's been having some super cool discoveries this past year.
Yeah. I mean, espresso is this prototype technology for direct imaging of exoplanets. That the technology that's being developed using this is going to be adapted from the Very Large Telescope, which can just barely do it with 4 giant infrared telescopes working together, to the Extremely Large Telescope, which is going to be 39 meters across, and then it'll work like a charm.
I'm still sad that they got rid of the Overwhelmingly Large Telescope and replaced it with the Extremely Large Telescope.
Yeah, the budget for the Extremely Large Telescope is coming in at $1.15 billion. And when they originally were thinking of the Overwhelmingly Large Telescope, they were seeing its initial budget was going to be about $1 billion, and they were like, "Oh, that's too much money. We can't spend $1 billion on a 100-meter telescope. That's too much money." And here we are, almost $10 billion in to James Webb. Yeah.
We don't mention JWST other than to say maybe it will launch someday.
It will absolutely launch on October 31st. It is done. It is packaged up.
Has it made it all the way to New Guinea without sinking yet?
No. So it still has to, make sure that the Ever Given doesn't block the Panama Canal this time. And it has to get through through pirates. And it has to make it through storms. But
like they aren't saying when they're going to sail the JWST because there are actual concerns about pirates.
Yeah.
Pirates.
Yeah, yar. So, but it is packaged, like it's not going to be opened up again. It's ready to go. Like if there's any other problem, we're going to find that out in space. I was actually talking to Jessie Christensen this morning about, and we were talking about planets and tests, et cetera, but she mentioned that JWST is going to take 30 days to open up, to assemble itself. 1 whole month of de-origami.
The slowest mechanical anti-origami that has ever happened.
It's crazy. It's madness. Yeah, unbelievable. So,
yeah. until it is actually in space.
I know.
I'm going to go with maybe.
I know. That's like, we're going to have just this triumphant episode called the James Webb Space Telescope. People have been waiting a decade for us to make this episode. But Pamela's got these rules. So, yeah.
Yeah, and like I remember when we were first starting the show, they were inviting us out on our own dime, so it never happened, to Goddard and some of the other facilities to do all sorts of recording behind the scenes and everything. But first of all, we didn't have the money. And second of all, we just don't generally do shows on non-existent technology.
You don't.
Well,
that's my bread and butter.
I understand. This is why you could talk about espresso better than me, because I wait for the science papers.
Yeah. But yeah, no, I love to talk about telescopes that will probably never exist. That's like my favorite thing.
You just like having your heart broken.
I love clever ideas. Like the thing that I love the most is when a person comes up with a really clever idea to solve some problem, and whether or not it's even better when it gets implemented and you see it all the way through. But even to just someone to just say, like, again, with this interview with Jesse this morning, we were talking about the orbit that Tess is on and how brilliant it is. It's on this lunar resonant orbit where it goes way far out, comes really close to the Earth, dumps all its data, flies back out far away, and the moon keeps it in position, and so they need to use pretty much no propellant. And so smart.
And it's such a tiny spacecraft. It's one that I want to say is like 700, 800 pounds.
Yeah, she said it has 4 100 millimeter telescopes on it. So the one behind me, this one, it has 4 of those. Are its main mirrors, or I guess main lenses.
And they launched straight into the phasing orbit, bypassing low Earth orbit entirely, just using a Falcon 9 because it didn't weigh that much. And I love this idea of, if you use a big enough rocket and a small enough spacecraft, you can do whatever the heck you want. And this starts to open up the possibilities. We get more heavy lift vehicles of just like, next time there's a extra solar comet, we just run that puppy down. Just run it down.
Yeah. I'm sort of like imagine a Hubble that would fit inside a starship. So like
there'd be so much room to spare.
Yeah, but you just like a 9 meter. Like when you think about, say, Herschel. Herschel was, if you look at the Herschel Observatory, it was designed to fit perfectly inside an Ariane 5 meter fairing. It with like a little bit of room to spare. The telescope looks like it's this tube that fits inside the launch fairing, and away it goes. And so imagine you had a 9 meter fairing, you could get maybe an 8 meter space telescope without any fancy folding, like just straight up a tube with a mirror, send it to space.
And none of the terror that we're going to go through for 30 days if JWST launches.
Yeah.
As it unfolds itself. Because there have been so many folding issues. Hubble had one. Galileo never got both of its antennae working, if I remember correctly.
Nope.
There's just folding issues.
Bad.
It's a problem, people.
Trouble.
It's a problem.
Yeah, don't do it. Yeah, I think we make cylinder telescopes. You just cover a cylinder in solar panels, so you don't even have to fold out the solar panels. Just maybe an antenna, but that's it.
Sometimes you do need that umbrella of a shield for infrared thermal issues.
Right.
But yeah, you simply launch a tube that has the shield wrapped around it and it unfolds. Nothing else.
You said the word fold. No, it's out. Yeah. No, okay. just like have it hiding, have a tube with a smaller telescope, a smaller tube inside.
That works.
Yeah.
That
maybe
does work.
6 meter telescope inside an 8 meter tube. What is this? Some kind of tube? Yeah. All right. So a couple of you are mentioning, Paul Disney says, if it sinks, I'll cry out an entire new ocean for stuff to sink into. And then Arjone says, sinking? I didn't even think about sinking.
You people clearly have not mastered the fine art of worst casing things.
Yeah. TP Seeker says, but will they be able to update will they need to update all the computers due to how long it's been taking James Webb? So like why? And Rich Wilson says Y3K. Oh, zing. Oh. There you go. And Bob Capello is saying that Compton Gamma Ray Observatory had an antenna that didn't deploy, requiring an emergency spacewalk.
They were all prepped to do a spacewalk with Hubble when they realized it was a software bug, and they just resynced the software and it worked.
Yeah. So even an antenna can't be trusted to unfurl itself. Although people have a lot of practice at this point. And no reaction wheels. I think just like make your telescope just tumble. There's just no, forget it. You got to figure out a way to make your telescope not be able to point. That's in addition. So
there are more than 300 single points of failure on JWST.
I talked to an astronomer about Hubble, and he said that Hubble is about 10 times oversubscribed.
Mm-hmm.
So more Hubbles would be great. Well,
and that's what W First is essentially going to be, which is now the Nancy Grace Roman telescope.
Yeah.
So yeah, we have to keep remembering JWST is an infrared observatory. It is a follow-on to was it Herschel that was the lagging orbit that just got turned off a year or so ago?
Well, yeah, Herschel was shut down.
Spitzer. I'm actually thinking of Spitzer.
Oh, okay, yeah. So I mean, both Herschel and Spitzer were recently shut down, but sure.
Yeah. So Spitzer was, it was meant to turn off nearly a decade ago when JWST was supposed to be fully checked out and functioning.
Yeah. Yep. Yeah, I guess as Elon Musk says, the best part is no part, and 100 and however many various actuators is parts, many parts. What's happening? What have you got going on? What should people come and check out?
So the big thing we're working on planning right now is this July we're going to be doing CosmoQuest again, and I need to get with you to get you on the schedule. This year we're doing a celebration of the 80s space. So come in your neon best with your biggest hair or a wig. And be ready to celebrate the 40th anniversary of the first space shuttle launch, the 40th anniversary of Voyager going past Saturn, and all the other remarkable stuff that is only happening because, well, the 80s got it all started.
That's awesome.
So you can get tickets at cosmoquest.org.
And this one is going to be another virtual event as well. Yeah.
Yes.
And more daily spaces, more stuff. What are you guys doing
always
with the rest of it?
So we're going to take May the 4th off because May the 4th be with you. It is an official holiday around CosmoQuest. So we will be back next Wednesday with Rocket Roundup at 2 p.m. Eastern. That is noon? No, it's not noon. It's 11 a.m. Pacific.
11 a.m.
Math is hard.
Yeah.
And oh my goodness, so many launches. 6 launches so far, and we still need to wait and see what SN15 does or does not do, and Crew 2 landing or not landing.
And the Chinese just launched their space station. Yeah, it's been a busy.
There's so much going on, and the science continues.
Cool. I've got a bunch of great interviews this week on my YouTube channel again. So if you wanted, Jesse Christensen was this morning. So definitely come back to my YouTube channel and check out all the cool interviews. I hope you're enjoying them.
Awesome.
All right. Thank you, everybody, for joining us this week here on this show we call Astronomy Cast. Thank you to all of the moderators. Special thanks to Beth for keeping the time, and all the fans watching both on YouTube and on Twitch. And thanks, Pamela, for bringing the brain. And we will see all of you next week. Thanks, everyone.
Bye-bye.
Find the button.